we talked about the first derivative, and notice we called it the first derivative. We didn't just call it the derivative. The reason for that is there is a second derivative. Second derivative, notations. Y with 2 dashes. F double dash x. D2, and then the function in braces, dx2, or d2y dx2. The first time people see this, they think, oh, all we've got to do is square the derivative. But those 2's are not meaning squared. So it means the second derivative. Second derivative, well, let's do one. Y equals 3x squared plus x plus 2. There's our first derivative. To find the second derivative, we just differentiate again. So you just differentiate the first derivative. So the second derivative measures how the first derivative changes. Square root of x squared plus 3. Well, I've got to put that into index form before I can differentiate. So to find the first derivative, bring down the power, lower the power, diff the inside, tidy that up. Now, to do the second derivative, I'm going to have to use a product rule this time, because I've got 2 functions of x there. So write down the first, x. Diff the second. To diff the second, I'm going to have to use the chain rule. Bring down the power, lower the power, diff the inside. Plus, write down the second, diff the first. Tidying that up, it's probably how a mere mortal might leave the answer. But we can factorise that because we notice it both have x squared plus 3 to the power of something. And minus 3 on 2 is the lowest power, so that's what I'll factorise out. And then to really make it look fancy, I can get rid of the negative and fractional indices, and we have 3 on x squared plus 3 root x squared plus 3. There's our second derivative. That's all for now.